Hey, thanks. Just to start with, I wanted to say thank you for having me back. I'm glad to get to come back and talk a little bit about what is new with DAOS on our journey forward. Just as a bit of a review, perhaps for folks who weren't able to join us as we talked about DAOS at Tech Field Day in the past. DAOS is a distributed parallel file system that we're building here at Intel. That's really based on Intel's Optane persistent memory, as well as our NVMe SSDs. And the general architecture for DAOS effectively splits the media into two tiers. So we take our metadata and small IOs, and that is stored on the Intel Optane persistent memory, whereas our larger bulk IOs are stored on NVMe SSDs. And the reason we did this is it was an intentional design to overcome a number of industry bottlenecks that we saw that were really inhibiting, storage from reaching the full capability of what the Optane hardware was able to deliver. In particular, I think for many decades now, I/O has been fundamentally block-based. Most storage, right? It approaches it, it writes all of your data out into blocks onto an SSD, because that's all that the media has been capable of delivering. But when Intel developed Intel Optane persistent memory, we actually saw that as an opportunity to think of storage in a new paradigm where we could use the persistent memory devices not only as storage, but actually go ahead and use them as byte addressable in that storage as well. And that ability to store your data in individual bytes as opposed to having to write them as large-scale blocks allows us to have a much higher performance and lower latency when it comes to delivering smaller IOs that wouldn't be able to fit, nicely inside of blocks. This is really designed to hit a number of different target markets. I think some of our most common ones we talk about are HPC, AI, and some of the high performance data analytics markets, though DAOS also has a lot of use cases in other scenarios as well. We have a prototype right now of doing SQL databases over DAOS. Someone's using DAOS, for a mail server now. There's a lot of different applications of this technology. But, the real key value story there is, really high-end performance, giving you sort of the best IOPS and bandwidth per dollar. Now, some of the challenges of bringing out something like a new parallel file system, a lot of that also has to do with industry adoption and really being able to be adopted by the ecosystem. So one of the things I wanted to talk about in our update today is just some of the progress that we have made on that front. Taking in a new distributed parallel file system is never particularly an easy task, right? When you look at something like DAOS that has sort of fundamentally moved away from being a block-based POSIX-based file system, you get even, so additional complexities in adoption. But we're really pleased with the progress that we've made so far, on the hardware partner side. I think, folks like Hewlett-Packard and Lenovo have made a lot of public statements about DAOS already. They've presented at DAOS user groups. We're starting to see that set of partners expand as well. In more recent times, we have expanded our partnerships now to include Supermicro, Inspur, Atos, Quanta. That list is growing itself, seeing more reseller partners as well, partnering with Colfax, Megware, RSC, 2CRSI, and then also working with additional partners to help create more of the ecosystem around DAOS itself. So we've been working with a third-party support called Croit, who's been doing a lot of work about making DAOS very enterprise friendly and adding another layer around DAOS to make that easy to be adopted by the enterprise. We've also had a long partnership with Bright Skies, who's added a lot as well, and our newer partner Netrix. We're also starting to see the emergence of more end customers as well, and starting to really see DAOS start to get established in the end customer market. I think Argonne's been known for a while. We've talked about that before. That's the big supercomputer with Argonne National Lab called Aurora, where there's going to be a 230 petabyte DAOS system there. But also with some different sorts of customers going forward. We've got work with Rugen Hospital, with Jenner, with University of Cambridge. So we're really glad to see also our end customers are getting very excited about DAOS as well, in addition to our partners. And, you know, some of them are wanting to start to demonstrate what they're able to do with that. This is some data from the most recent, this past June, IO500 list. For those who aren't familiar, IO500 list operates very similar like the top 500 supercomputer list, but it's ranking your top file systems in the world versus overall supercomputers. And we see that there were a number of new DAOS submissions this year, and we're really glad to be able to see, you know, some of our partners starting to do their own postings as well to be able to demonstrate the performance that they're able to get off of their platforms, as well as just to start to see more and more DAOS presence on the list, right? So this is the full overall list now, and you can see at this point, 5 of the top 10 systems on the list are now DAOS systems. You know, our systems continue to be of a notable smaller scale than a number of the systems around it. You know, I'll highlight our top one here. This is one we submitted ourselves. This is actually also our 10-node challenge submission. This only has 10 clients to the system, and we had number 2 on the list. Those were Ice Lake clients. Also, there is a 10-node challenge where everyone's limited to exactly 10 clients as well. Again, seeing, you know, strong presence of DAOS here. There's 6 of the top 10. You know, one that we think is particularly neat as well is there is a super micro system here as well now that's actually only 4 servers. This is an entry that has Ice Lake servers in it, not just clients. And actually you have to go down, I think, you know, well into the 20s in rankings to find anyone else who has that small a number of servers in comparison to their score. So we're really excited as well, looking forward to see more Ice Lake systems be able to appear on these lists. And just the last one I wanted to highlight from that as well. So, you know, in that 10-node challenge, our Intel Endeavor system with DAOS did also get the number 1 score in overall bandwidth as well. That's about, you know, almost 400 gigabits per second. So, you know, that's actually more than twice as high the next highest score in bandwidth for that as well. So I think we're still showing, you know, a really healthy presentation for maintaining leadership in performance with the DAOS solution. But that aside, I want to talk a little bit about what's coming up with DAOS as well. So since we last met, we did finish and release the DAOS 1.2 community release, but we're also now starting to approach our DAOS 2.0 release just after the end of this quarter. And I think it brings forth some notable features that I wanted to be able to highlight for folks. A big one is going to be, from a pragmatic perspective, is going to be CentOS 8 support. You know, having that support for CentOS 8, of course, is very important for folks building Ice Lake platforms. But the really big highlight feature for this release is our erasure code feature. So this is something that's been a long time in development now, and I'll dig a little bit more into the details for that coming up. We're also adding the ability to reintegrate and drain nodes into your file system. We call it quiescent reintegration. At this point, that reintegration does require you to not have any active IO on the system. Being able to have fully online with active IO server reintegration edition, something that's going to come up in our 2.0 or 2.2 release. Sorry. This is also the release where we have added a lot of our telemetry for being able to monitor the performance and status of your DAOS system, and have provided a basic Grafana dashboard for open source users who want to be able to have a quick dashboard. I know a lot of our partners are also developing their own displays for that telemetry. We also are bringing support for the TCP libfabric provider. So this allows us to really extend DAOS into Ethernet networks as well, outside of its current InfiniBand support matrix. And really a lot of focus this release, much more than new features, has been on improving the overall stability, usability, and documentation. We really believe that, that stability and usability are cornerstones of a new file system being able to be successful, and equally as important as an impressive feature list as well. So I thought I'd talk a little bit about our erasure coding. So for those who maybe aren't aware, up to this point, DAOS has had replication, N-way replication for its data protection. But there's some definite downsides to using replication. The main one, of course, is just hardware efficiency, right? If you've got to keep N copies of your data around, you have to have that much additional storage hardware available, which can become expensive as a solution in the long run. So erasure code's been something a lot of our partners have been looking forward to. So that will be, sort of production ready in this 2.0 release. Basically, the way our erasure coding works is that our clients actually can reconstruct their erasure coded protected data in flight, taking surviving data pieces from a node that's no longer available in their parity, and then be able to use that to reconstruct the data to still be able to read, so the file system can still keep performing. While clients can reconstruct the EC protected data in flight, in the meantime, the DAOS file system also has a self-healing service that gets scheduled in the background, which, similarly to how the clients are reconstructing the data, in this case, the servers are reconstructing the missing data pieces from the redundant data and are able to store newly reconstructed data onto fallback nodes. So eventually the user data recovers back to the same redundancy level, minus, even though the node that has failed is now missing from the cluster.
Hey Kelsey,
Yep.
This is Ray Lucchese. Good to see you again. What's a typical DAOS customer environment look like, and size and files and stuff like that? Is there such a thing? I don't even know if there is such a thing.
There's a really, really big variety to the size of DAOS systems we're looking at, right? We have some folks who have 4 DAOS servers. And as I mentioned, at Argonne, we're going to be deploying 230 petabytes. So I would say the size runs the complete gamut.
And a 4-server environment would be a petabyte or so kind of thing?
It's going to depend a little bit. So the way the capacity of individual nodes for DAOS is determined is based on a ratio of persistent memory to disk. So you need to maintain about a 6% ratio between your persistent memory and your NVMe SSDs. That ensures we have enough space in the persistent memory that we can store all of the DAOS metadata necessary to locate your data inside of the SSDs. Because if you recall with DAOS, right, we're not using the persistent memory as any kind of buffer. We actually use it as a first-class storage device. So we need to be able to have enough space there to be able to do what we need to do. And all of the information inside of DAOS as to how your data is laid out on the SSDs is stored inside of that persistent memory. So that's why the ratio there.
All right.
But I would say the most common deployments we're seeing today, aside from a few larger systems that we're seeing with some labs are roughly on the 1/2 to 1 petabyte scale.
All right.
Kelsey, I have a question about erasure coding and also the other features that you are adding. What is the impact in terms of performance? Because some of these features can really have an impact, especially when you have to deal with the write performance.
Yeah, I mean, it's certainly never free, right? You're never going to get erasure coding for free. And, I think one of the most challenging aspects of erasure coding is particularly when you're doing partial stripe overwrites, which normally sort of requires you to do a read, encode, write, and a bunch of distributed locking, which is very inefficient. But one of the things we're able to do with DAOS, because the DAOS data model is actually a version data model, not just written over in place, the clients can actually directly submit partial overwrites to storage, and then the storage servers can merge the data versions and re-encode the data in the background. So with DAOS, we're able to take a much lower performance hit than would be typical for most erasure encoded solutions. So there's, of course, an impact, but we think folks will find it a more acceptable impact than potentially other erasure coded solutions out there. And in addition to that, I'll remind that DAOS data protection is also something that's controllable per object as well. So you only need to pay that cost on the data that you want to have that type of protection. And if you have other data that's maybe scratch, or you'd go back to a restart if there's a failure or something, anyways, you can choose not to have it protected with this. Or to have it protected with replication if it's important to be protected, and also not have that overhead, and really fine tune to pay the cost just for the data that needs that level of protection.
Do you have the same limitation that we usually see for erasure codes? I mean, large files work way better, and small files are not really efficient to be compressed in this way. Sorry, protected in this way. I mean, what is the limitation?
There's some things that are fundamental to erasure coding in general, but I think that because of the things I kind of already talked about with the versioning and things like that, you see some less inefficiencies than you would otherwise. I think going forward, we're going to do some more formalized publication of data to show some exact comparisons. I'm sorry, I don't have that exact comparison data to be able to share with you today because we're still wrapping up the feature at the moment. But once the feature has reached a finalized enough state that we feel we are able to publish the benchmarks we have, we can share some more specific data for specific scenarios.
Thank you.
I have another question, Kelsey. This is Wolfgang.
Yep.
Specific to the erasure coding, do you use a one-layer erasure coding, or is it a two-layer in terms of some global and local erasure coding?
I believe it's just one, though I will admit I might have to defer to our lead developer on the feature to ensure the answer to that's correct. Sorry about that. Okay, I'll just touch on a couple other points that I didn't get to before on erasure code. I just wanted to mention, so I was talking about how its self-healing service gets scheduled in the background while IO is still actively going on in the system. So eventually your system does get back to the same redundancy level as it was without that node. And then your application can access the data in a regular mode, and it's no longer having to reconstruct the data on the fly. So it goes back to the same performance level that you would have during regular mode and avoid the performance data that you would see while you're in your degraded mode. So the other aspect I wanted to talk about as well then, we're talking about nodes failing out and going away. Well, the other natural hand to that is being able to add the nodes back in, right? You have a node, maybe it failed in some way, an SSD failed, et cetera. It's been, there's sort of two parts to that system of what to do in response, right? So our self-healing system in general has two components, right? You have to have the notification that there's been a fault So the first part of our self-healing system is health monitoring. That's based on a gossip-like protocol, which allows us to detect node failure in a really bounded time and be able to report the event if the node is faulty. And then that second component to that is reconstructing the missing data pieces, which is either done from the data replicas or the EC protected data, as we just talked about. And so we sort of look at the two parts. Because we're using algorithmic data placement based on a deterministic pseudo-random algorithm, the data servers of DAOS can really independently discover objects that are impacted by the fault and be able to reconstruct those missing data pieces in the background. But then there's what happens after that, right? My data is reconstructed. I need to bring this node back into the cluster. So that's what we are calling just simply reintegration, how to bring it back in. Obviously, a very important feature of any parallel file system, so that you're able to reintegrate the storage server back into the storage pool. In this case, you're going to need to take all of the data that had been reconstructed on the other storage servers, move it back to the reintegrated server, and the servers that got involved previously in the data recovery can then free the extra space that they were storing the additional data protection in, so that at the end of this reintegration activity, the whole DAOS storage system is then restored back to its original performance and capacity as well. So while maybe obvious there's something we need to provide, we're glad to be able to have this feature coming out now as well, to be able to support really a full life cycle of storage systems going forward into the future. And as I mentioned, right, we'll be able to do this fully online while IOs are still in flight in the following release, in the 2.2 release.
Hey, Casey, does storage nodes have to be equivalent in capacity and performance?
The way DAOS is today, yes. Yes, we do look for the nodes to be homogeneous. That allows us to make a number of assumptions that allow us to keep our data placement very consistent and algorithmic, right? You want it, you could put heterogeneous hardware together, but you're basically going to have everything leveled out to your lowest common standard.
denominator. I got you.
Mm-hmm.
All right, thanks.